Hello, everyone. Welcome to Cassandra Lunch number 105. We'll go ahead and get started soon shortly. Hello, everyone. Welcome to Cassandra Lunch number 105. Hello, everyone. Welcome to Cassandra Lunch. We'll give everyone another minute or so to file in, and we'll get started soon. Alrighty, let's go ahead and cut the music. Hello, everyone. Thank you for joining us here for Cassandra Lunch number 105. Today's talk is going to be on Cassandra, Presto, and Airflow. I'll be the speaker for today. I'm an engineer here at Anant. Co-organizers for this event are Rahul and myself. If you are interested in giving a talk here at Cassandra Lunch or our sister lunch, Data Engineers Lunch, feel free to reach out to me. My email is listed below, as well as if you're interested in sponsoring Data Engineers Lunch or Cassandra Lunch, feel free to reach out to me as well. We're a part of Data Community DC. Data Community DC believes in building an inclusive environment, so no matter your race, gender, sexual orientation, everyone is welcome and we expect the respect to be given to all. Data Community DC is built of a bunch of different organizations. Our sister launch, Data Engineers Lunch, falls under Data Wranglers DC. You can find out more about all the various organizations as well as events at datacommunitydc.org. So what do we cover here at Cassandra Lunch? We cover everything that is Cassandra, talks Cassandra, or plays well with Cassandra in the ecosystem, such as open source Cassandra, DataStax, Scala, Yugabyte, Cosmos, Keyspaces, as well as things in the ecosystem like Spark, Kafka, Presto, Airflow, which we'll be talking about today. If anyone's new here, feel free to drop a comment on the YouTube chat. If you're watching this on YouTube, don't forget to like and subscribe and turn on the notification bell so that way you do get notified every time we do go live. If you have a question, please ask it. This is meant to be community. So if you're interested in something or if you want to comment on something, feel free to do so. But obviously, please be polite and courteous to the guest speaker and respect their preferences. But again, this is meant to be community. So the more you know, the more everyone will know. Here at Anant, we design, build, and manage global real-time data and analytics platforms surrounding Cassandra, Spark, and Kafka. So Cassandra is our bread and butter. DataStax is a partner and a sponsor. GW University helps provide venue space when we have in-person events. We also have some organizational institutional sponsors. If anyone has any jobs they would like to offer, or if they're looking for a job, feel free to drop links and we'll get them transferred to and from. If anyone has any meetups, hackathons, conferences, classes they would like to promote, again, feel free to drop links. Anant is hiring full-time or part-time positions, data platform operators, engineers, or architects. You can find out more at careers.anant.us. Again, every Cassandra Lunch happens on Thursdays at noon Eastern. We are looking at having a more variable time slot so we can cater to a live worldwide audience, as well as Data Engineers Lunches, which happen on every Monday at noon Eastern. And on the next upcoming Data Engineers Lunch, we'll have guest speaker Will Angel, who'll be talking about DevOps fundamentals. So if you're interested, feel free to check out and stick around and subscribe for that. All these videos are available on our YouTube channel, youtube.com/AnantCorp, all the way from Cassandra Lunch 10 up until today. All of them are recorded and live streamed directly to YouTube. Cassandra.Link should be no more resource for all things Cassandra. This is a hand-curated site by the team with all things Cassandra-related articles, videos, news feeds, etc. So feel free to check it out if you have any Cassandra questions. We have released our 4th Apache Cassandra runbook on disk and CPU resource management on Cassandra cluster. Get it while you can. It's for free. It will be gone either next week or the week after, so be sure to get it while you can. I'll drop the link below so you can grab it. And I'll drop it in the YouTube chat, and I'll also drop it in the Zoom chat. And with that, we will go ahead and move over to the talk for today. Can everyone see the new slide deck?
Yes.
Great. Okay. So preferences, I'm not too picky in terms of questions. If you have a question, feel free to ask it, speak up, or if you feel more comfortable, feel free to drop it in the chat. I have the YouTube chat open, so I'll be able to see the questions coming from YouTube as well as the Zoom chat here. So today's talk is going to be on Cassandra, Presto, and Airflow. If you were here with us a couple weeks back at Data Engineers Lunch, I talked about Presto and Airflow, and I also had Presto connected to Airflow, or Presto connected to Cassandra. But again, we were just mainly focusing on how to connect Airflow and Presto to orchestrate your SQL queries with Airflow using Presto. So today's talk is going to be more focused on connecting everything together. So actually using Airflow to orchestrate SQL queries on a NoSQL database like Cassandra. And so we'll show you how you can do a read query. You can show you how to do a join query. It's the same as the read again, but to show you an extension of the joins, we're going to show you what queries look like when they come back from Presto, as well as how you can flatten the list of lists that come back. Again, it's just Python, but then and then how to write a query using Presto to Cassandra, and some things that you have to keep in mind when you do that. So if you're not familiar with Presto, we have a couple talks on Presto, but essentially it's an open source distributed SQL query engine for big data. It originally came out of Facebook to solve slow queries on like massive data warehouse. And then the original open source version that we're going to be using today is going to be called Presto DB. So when you're searching for Presto, some things might come up, right? You'll see Presto DB, you'll see Presto SQL, you'll see Trino, you'll see potentially Starburst as well, right? So the one that we'll be using today, which is the open source version, which is Presto DB. And then you might see Presto SQL / Trino, which Presto SQL is now Trino. That is another version that was worked on by the people who originally created at Facebook and then eventually left to continue working on it. And then you also see Starburst, which is an enterprise level of Presto. And so Presto is designed and written from the ground up for interactive analytics and approaches speeds of commercial data warehousing with scaling to the size of organizations, enterprises like Facebook. Single Presto query and why it's so powerful and people like it is that it can query data from multiple data sources within a single query. And you can do analytics across your whole organization. So you can essentially query data where it lies. So for example, today we'll be using a single Cassandra catalog, but if we wanted to, we could have multiple Cassandra catalogs pointing to different host names and then combine those into a single query if we wanted to. Because the way that you write a Presto query, it's dot notation similar to you pick your catalog, then your schema, then your table, right? And so companies like Comcast have Cassandra, SQL Server, Mongo, Oracle, and Teradata, and they can use Presto to query across all of those. And some other more recent companies that use Presto are like Airbnb and Dropbox. So you can imagine how much data that they have. They need to use a SQL query engine, either Spark or Presto, to do their interactive analytics. So if you're not familiar with Presto, if you're using the CLI, we'll talk through it here, is you have the Presto CLI, so you'll need the web server, you'll need the server to be running, and then you use the Presto CLI executable. And then here, what they're saying is they're picking a specific catalog, which is catalog Hive. So this is their Hive catalog. In that catalog properties file, you define wherever you're porting to, ports, etc. We'll talk about that once we get to the Cassandra section. And schema is, again, for us in Cassandra world, it'll be our key space. And then again, you can just say select whatever columns you want, and then you select from default Wikistats. So following dot notations, because they specifically specified what catalog they're using when starting up the CLI, they don't have to have the extra level of hive.default.wikistats. If they just said Presto CLI, and that's it, then they would need to say, again, hive.default.wikistats. And again, when you return your data, you write your query like a SQL query because it's a SQL query engine, and you get your table or your data returned in tabular format, as well as you get some stats related to your query. And we'll take a look at that in the Presto UI as well, which is here, which when we pull up our repo here, we'll show you how to do it. This entire demo can be done via your browser. You could even do it on your tablet. It's done via Gitpod. But if you have Docker, you can also do this all on Docker as well. And again, in the Presto UI, you can see metrics. And if you want to find out more about the Presto UI, you can check out our Presto and Airflow talk. I won't go too deep into the Presto UI today, but you can find out what we talked about on our previous Data Engineers launch on Airflow and Presto. So some links that might be useful for you, we'll cover these when we're waiting for some stuff to load for the demo portion, but essentially it's the documentation for the Presto hook that we'll be using today, as well as the Presto documentation for the Cassandra connector and some things to keep in mind, as well as some additional things you could have that if you wanted to. And so today's demo is going to be focusing on spinning up the Docker and containers on Gitpod. We are going to connect Presto and Airflow, and then we're going to run 3 Airflow DAGs that I've created for you. So again, the first Airflow DAG is just going to be a simple read from Cassandra and see what the data looks like just on a basic read. Then we're going to do a join query, which again is the same thing as a read query, but then we're going to pass that the XComs that come back from the read query, and we're going to pass those into a secondary task, which will show you how you can flatten it, as well as if you want to go deeper, etc. And then the last query will combine everything, and then we'll use the flattened, or we'll use the XComs that come back, and then we'll write those into Cassandra, into a new table. And so with that, we will go ahead and switch over to the demo here. So what I'm going to do is I have this on a second screen. And so I'll just be following the README. There are a couple steps that I'll be doing ahead of time because the Airflow scheduler defaults to, I think, 5 minutes. So what we're going to do is we're going to run some of the commands that move the DAG files into the DAGs folder ahead of time. But generally, you can just follow this top down. It doesn't take very long to do the demo. But what we're going to do is we're just going to open this on Gitpod. I'm going to close out of this for now. And so while this spins up, what's happening is, I mentioned it in the Airflow and Presto talk previously, but I am working on creating a Docker Compose file that will do all of this for us. So it can just be a Docker Compose up. But again, I'm still working on it. I haven't gotten all the kinks out. So this is a working version for now, but there's always ways to iterate on it. And we will iterate on it because I do want to bring Spark into this talk as well. So you can see comparisons, you can see potentially how Presto and Spark can work together, et cetera, et cetera. So what we're going to do first is, I'm just going to switch tabs here, is we are going to run our setup script. And so a lot of this, if you were on our previous talk for Presto and Airflow for Data Engineers Lunch, it's all the same up until we get to the DAG sections, which are going to be a little bit different. But for the most part, if you were here for that talk, it's going to be a similar process. So what we're doing here in setup sh, we are going to run the Presto container. So there's a couple of different Docker containers. We talked about that previously. Presto DB Sandbox is an open source one, and then, or open source Presto container, and then Cassandra, we're just using the Cassandra container. And then we're going to install Airflow. And then we also need the Presto provider, which is important because that's what actually helps you talk to Presto via Airflow connections. And then we're just going to create some basic user. And then because Presto UI starts on 8080, and I haven't done, or the Docker file, I'm still working on it, but eventually we'll change up the ports. But for now, default Presto UI runs on 8080, and then we just changed the Airflow web server to run on 7080. So as you're running this demo, before I do that, actually, let me drop the link to this in the Zoom chat and the YouTube chat in case you want to follow along. So what we're doing here is, as these come up, we'll see a little dialogue here on the right-hand section to make ports open, and we can just hit make public, so that way everything can talk to each other. Okay, so while this is happening, let's take a look at the Presto hooks documentation. So there's not a ton of examples out there, so I want to say some of our examples are more the helpful ones for using Presto, Airflow, and Cassandra, because in the documentation here, this is all about what you get for using the Presto hook. There's a couple of different things you can use here. Insert rows. You can also use the run method. And we'll talk about that once we get to the demo portion, because I tried playing with them. They don't work great, or maybe I was doing it wrong. But from what I had tried so far, it looked right in the logs, but it wasn't actually writing anything to Cassandra. So I think it was maybe creating a view or something in Presto, but neither here nor there. We'll cover that once we get there. But so I'm just making these public real quick. So coming back to here, if you click on this example DAGs for the Presto connector, we see two, right? We see this GCS to Presto, and we see this Presto to Slack. So clicking on this here, it's not like super helpful. Like, this is a specific connector built for it. So this doesn't actually show you how to use like Airflow and Presto just straight up. It shows you how to use GCS to Presto, but it doesn't actually show you how to just straight up use the PH connection, right? All right, so now that those are coming up, but before we get to there, I'll also want to cover the Presto and Slack one. Again, it's similar to what the example was previously. It kind of just has your SQL query here, right? It has an F string, uses a variable, and then it just says my Slack channel, whatever, right? So what we're doing ourselves is we're specifically using something like this, right? We're not We're not sending it somewhere. Well, we are sending it to Cassandra eventually, and we'll talk about that once we get there. But just to straight up run a Presto query with Airflow, there's no good example for actually how to use a Presto hook. So hopefully this can be helpful for everyone here. And all of it's available on the GitHub repo that I linked to in the Zoom chat, as well as the YouTube chat. So coming back to here on our terminal, now that we have all of our services running, we are going to open up port 7080. And again, nice thing about Gitpod, everything is browser-based. And so you can do this on whatever machine you would want. Okay, so now that we're here, one of the first things we need to do is set up our connections. And if we just search for Presto, we go into edit record. So you saw how that automatically changed. So again, as mentioned, if you don't download that Presto provider package that we have in our setup script, it would probably default to something like email and it wouldn't actually work. So make sure, again, it's mentioned here, you download the corresponding Airflow provider package. And so what we're going to do is we are going to update our host, which we're going to grab by just running this command right here. And then we are going to paste that in. Again, this is similar to, remember how we talked about the schema and the catalog? You can preset whatever you want to use, and Airflow will pick it up when it's using the default connection. However, because we're using Cassandra and we want to say, we're going to be using the same schema / key space. But if you had multiple key spaces, you can leave this empty, and we'll be leaving this empty for ourselves. For the login, we're just going to use admin, and we're going to switch over the port to 8080. And you can hit test here, and you'll see that connection was successfully tested. And the cool thing here is you can actually open up the Presto UI on 8080, click the finished queries, and you'll see here, you see a select one, and you can see that it actually sourced from Airflow. So Airflow actually sent a quick query to Presto. It came back finished successfully. So it said, okay, I tested the connection, it's connected. So I'm going to close out of the Presto query because we don't really need it, or Presto UI, sorry. So what we're going to do now is we are going to update our Cassandra properties file, which is again how we define, or sorry, our Cassandra properties, which is our catalog file. And so this is where we define our Cassandra connections, essentially. So in the Presto documentation here, this is the basic one, connector name, and then the contact points. We just have a single Cassandra node, right? So we're just going to have one. But again, you can set a bunch of different configuration options. If you have username, passwords, allow drop table. If you want to set a specific consistency level based on what kind of queries you're running, you can set all of that. But ours is going to be very basic, just the connection name and the host name. But again, there's more connections you can have here. And something we'll talk about is this data types, and we'll get to that in a second once we get to further in the demo. But coming back here, let's save this connection and let's go to the properties file. We're just going to run a quick set replace. And then what we're going to do is we're going to put this onto the Presto container. And so just to confirm that it's there, we're going to run an ls command, and we see that our properties file is. So when you're creating your catalogs, you need to put them into the etc catalog directory. And again, we talked more in depth about this during the talk on Airflow and Presto for Data Engineers Lunch. So if you want to find out more about that, feel free to check it out. Okay, so coming back here is we are going to start the Presto CLI. Let me expand this a bit. And we are going to run a show catalogs command. And so you see here, we don't see our Cassandra catalog. And so something to note is whenever you add a new catalog to Presto, you may need to restart the service in order to be able to see the new catalog. So what we're going to do is exit out of here, and we're going to do a Docker restart Presto. And so that's going to restart our Presto catalog or Presto container. And while that's happening in the background, what we're going to do is set up our Cassandra container. And so what we're going to do first is we're going to copy a setup CQL file, and we're going to put it onto the Docker container. But in this CQL file, we're going to be creating a key space. We're going to be creating 3 tables. So we have one table called spacecraft journey catalogs. It's going to have a spacecraft name, journey ID, start time, end time, is it active or not, the summary of the trip, and then the primary key is with the partition key of spacecraft name, clustering column of journey ID. And then we have about, I think, 1,000 records. And then we have a second table, which is spacecraft speed over time. So it's going to have the spacecraft, same journey IDs, the speed, reading time, speed unit, etc. And so what's happening here is I've reduced the data a little bit just to make everything faster and easily visualizable. Sorry. And so each spacecraft for the journey that it was on was clocked at 2 speeds. And so we'll take a look at that once we get to the portion during the join statements, because we're going to run these join commands, right? And then we're going to create a third table, which is spacecraft journey summary and speed, which is going to be the spacecraft name, the summary it took, and then the speed it had, with the partition of spacecraft name and clustering columns of summary and speed. So we've now put that onto the Cassandra Docker container, and now we need to run that CQL file, and we're just going to run it with the flag F. And so that's now there. And if we just want to check that, what we can do is just run flag E, select all from demo dot spacecraft journey catalog. And we get back data, right? So our data's in there. So I'm going to expand this again, and we are now going to, oh, sorry, apologize. I meant to run this beforehand, which is moving all the DAGs into the DAG folder. We're also creating this. So our DAGs are not actually here yet. I meant to run this ahead of time, so that way while we're talking through all the other stuff, that the DAGs would be ready by then. But while we're waiting on this, some things I want to talk about are, well, first, let me open up the floor to questions. Does anyone have any questions? If you're on YouTube chat, you can drop them, or if you're on YouTube, you can drop them on the YouTube chat as well. Okay, doesn't look like there's any questions. Okay, so coming back to something I wanted to talk about while we're waiting on these DAGs to get picked up. Let me see, 32, okay. So this data types thing kind of matters. So we see this Cassandra and Presto thing, right? So while I was working on writing to the Cassandra DAG from the Presto query, so like Presto join, take that data, write it to Cassandra, right? So obviously with Cassandra, you can't run join, so you need something like Spark SQL or Presto, right? But if you wanted to do everything in one query from one key space and then another key space, you can use Presto to do that. So one of our columns is a time UUID column, right? And that's for the journey ID, I think. And so it was having trouble recognizing that. So it recognizes as time UUID. Presto does its thing, it converts it to varchar. And so when I wanted to write that into Cassandra, in Cassandra, we want to keep it as time UUID, right? And so having to run types of conversions, or if you wanted to change it to varchar, so you can just strictly take it from Cassandra, put it into Cassandra again, into a new table, you would have to keep in mind these conversions that take place when Presto runs the query. So again, things like timestamp, time UUID get turned into, or sorry, time UUID, there's another one in here, like lists, maps, sets, they can get converted into varchars. So if you want to use Presto and then put it into Cassandra again, that's something you have to keep in mind when you're writing your insert queries, right? That may not be the case if you're using something like Spark, but again, if you're using Presto only, that's something to keep be cognizant of when you're writing insert queries back to Cassandra from a read query from Presto. So let's do a quick refresh here. Okay, so now we have 35 DAGs. So we've inserted our 3 DAGs. So coming down here, we have a Presto read from Cassandra DAG. We have a Presto join and XCOM DAG. And then we have a write to Cassandra DAG. So I'm just going to open these 3 up. And so what's going to happen here is we are going to go into our variables first because we need to create our variables. So what we're going to do here is we're going to create a Presto query variable. And then in the value, I just need to copy and paste it from here, is we are going to run essentially that same select all statement that we ran. Select all from, again, catalog, schema, / key space, and then our table, right? So we're going to hit and save. And we're going to go back to our read query. Okay, and let's take a look at the code real quick, right? So what we're doing here is we are going to instantiate the Presto hook. We are going to get the variable we just created, and we're going to essentially run this Presto hook get records, right? And then use the query that we have, and then essentially return the data. So what we're going to do is turn this on. Let's look at the graph view. Shouldn't take very long, and we see that's already completed. And we hit log, and then in this log, we see the returned value was whatever data we have, right? And so one thing to note is that it's a list of lists. So if you're doing post-processing on this query, you'll have to keep in mind that you'll need to abstract this list, or if you're going to explode it and then have your columns, you'll need to keep that in mind if you have a template schema, and then you explode it, combine it, etc. But one thing that I've noted that when using this like this, it seems that the entirety, it does return it in the column order that it's read from. So if you're using that kind of method, just keep in mind that you have to track, or you have to map it properly. So I would do testing, obviously, but again, main thing to note is when you use a get records query and you query from Cassandra using Presto, it returns a list of lists in Airflow as the XCOM, right? And a cleaner way to look at it, because it's pretty large, is right here, right? So we have all of this data that got returned via XCOM, or that's available now by XCOM. So what we're going to do is we're going to pause this DAG, and we're now going to move on to the join query. So going into the join query, what we're going to do is we're going to go back into our variables here, and we are going to edit our query. And we are now going to have a more complex query, but again, it's just a join query. So what we're doing here is we're selecting spacecraft name from the catalog table, the summary from the catalog table, the speed from the speed table, and then we're joining that based on journey IDs, because again, it's the same journey IDs and they're just clocked twice during the speed table. So if we hit save, and again, one thing to note, we're doing catalog.schema.table notation. If you don't have this dot notation, it will throw an error when you're actually running the DAG itself. So just keep that in mind. So let's go back to our join and XCOM DAG. So if we go into our code here, so the difference between the first DAG and the second DAG is now we have a second method and a second task, right? So the second task, which is just getting XCOMs, we're going to pass in the task instance, and we are going to pull in the XCOMs from the previous task of read from Cassandra, and we're going to, for XCOM in the list of XCOMs, print each XCOM. So ideally what we should get back here is each list within the list of lists on a single line. So that would replicate a single row for each thing returned. And because this join query is going to only return 18 results, is going to be much cleaner to see. Versus if we had a lot more data in the speed table, it would be a lot more data. But again, in the speed table, we only have 18 records. And so it's, I think for each spacecraft, we have 9 spacecrafts and each one got clocked twice for the specific journey, right? So what we're doing is then just setting up the dependencies of read from Cassandra and then do the XCOM task. And it's going to then display it. So if we come in, unpause it, and we go into graph view, we see that's already completed. So again, if we go into the log here from the first task, which is the read from Cassandra, so we see the spacecraft name, we see the journey or the summary of the journey, and then the speed. And again, because they're clocked twice for each summary or for each journey, we have the same spacecraft, same summary, and then another speed, right? So if we want to look at this in the XCOM view, again, it's a much smaller list. And then if we then go back to our graph and look at our XCOM get, and we look at our log file here, we see that each list within the main returned list has been broken up. So you can essentially correlate these to a single row each. So this is the first row, this is the second row, et cetera, et cetera, et cetera. So now what we can do is, using these lists, we can write them back into Cassandra, right? So write them into our third table, which currently has no data. So if I unpause, or if I pause this again, so now if I go to the right one, and we'll get to that in a second, what I want to do first is just confirm we have no data in our Cassandra container, or in that third table. And we currently have no rows, right? So we have spacecraft name, summary, and speed. So we want to take back the data that we got back via the join query, and then we essentially took each individual list within the lists, or each individual list within the list of lists. And we'll then write those into Cassandra. So what's going to happen here is we are going to look at the code first, because I want to talk about a couple different things here. So again, it's going to look very similar to what we did before. However, what we're going to do is, instead of just printing them, we're going to write a new Presto write query, which is going to be an F string. And we're going to insert into, again, using the dot notation, because again, this is a Presto query that we're writing into Cassandra, right? So it has to be a SQL query, not CQL. So we're going to define the columns that we have, and then what we're going to do is, for each XCOM, which is a single list, we're going to take index 0, index 1, and index 2, and use those as the values, and we're going to write them into Cassandra using the get records. So if you see this here, you're seeing why use get records to actually submit an insert query. So I played around with this. So in the documentation here, we see this insert rows, and there's also another method you can use called run. And so this run method, it actually like inputs whatever you're using. However, it doesn't actually write to Cassandra itself. And same thing goes with insert rows. And so what you do is you just have the table and the iterable tuple. And so what I did was just take the table we want to write to, and then I just did a tuple modification of the list of lists, because that's an iterable list, right? So it will take that list, and I tried it out. In the logs, it looks like it's working because it's saying it's writing to XYZ. However, when actually going back to Cassandra to confirm that it actually went through, nothing actually truly got written. And so what I noticed is when I use the get records, that actually works properly. So something to keep in mind, you might see ph.run or ph.insert rows. Potentially it's a user error on my part for ph insert rows. But from what I could get, again, there's not a lot of good examples for writing into Cassandra. It wasn't truly like a good, so whatever I have, I guess is the first true example so far. But coming back now, Again, just to confirm, we have 0 rows, right? So now if we turn on this DAG and we go to the graph view, it's going to read from Cassandra, and then it's going to write to Cassandra. And so we see here it's completed. So let's look at the log here. And so we see here that it's using connection Presto default for task execution. And again, because it's just a for loop, it's going to run it 18 times for however many rows we have. And so now if we go back to our terminal and we rerun this command, we now have data. And so we were able to run a join query on a NoSQL database using Presto on Cassandra and then orchestrate it via Airflow. And this kind of just shows you what you can potentially do with running repeated queries onto a NoSQL database using open source tools like Airflow, Presto, and Cassandra. This whole demo here is all open source, right? Nothing we're using here is proprietary knowledge or enterprise systems. So one thing I did when I was searching on how to write to Cassandra using Presto was this error. It's old, right? It's 4 years old. But one thing I did come across is that the Cassandra connector does not support create table due to the way that Cassandra has primary keys. However, it does you can use create table as select from. So what I'm going to show you here is actually something pretty interesting is if we go back to, let me turn this one off, and let's go back to our read query, and let's go to the variable. So we're going to change this query to now be create table test, or Cassandra.demo.test from or select all, or as select all from Cassandra.demo. Let's see, what was that table called? Let's just copy this. Go back into here, edit variable. Okay. So we're going to hit save. And then we are going to rerun this DAG here. Let's go to the graph view. Just go ahead and trigger it. Okay, so it's completed. Let's take a look here at the log. It's just saying it's using connection, whatever, right? So actually looking at this, the table that we created in Cassandra, if we do docker exec it Cassandra CQLSH, just to get in the CQLH terminal. So we'll do, I'm just going to use demo so I don't have to write so many things. So we're going to do is describe test, right? So we see here that it's created a new primary key, right? When we created this table via a Presto create table command, it's picked up our spacecraft name, it's picked up our speed, it's picked up our summary. So it's picked them up properly as double text and text. However, this is the weird thing here, right? So why did it create an ID UUID primary key? So if we actually do a select all from test, we see that it kind of messes up our data model, right? So that's just something to keep in mind if you want to do a create table as select from with Presto and Cassandra specifically, is that it's going to create its own primary key with UUIDs, and that's going to mess up your whole primary key, right? Because our primary key was spacecraft name, summary, and speed. Again, that would just make it a single. So if we wanted to just do it spacecraft name, summary, and then extra uniqueness, we had speed, so it didn't do an upsert. Last right wins. So that's just something I noticed while playing around with this, was that when you use a create table with Presto, it'll create it with the primary key column. That just keep in mind that can happen. But if you're just doing it as a insert statement, it does not do it with an ID. So yeah, that kind of wraps up the demo portion of today's talk. Open up the floor to questions. Let me switch over to the YouTube chat. If you're on YouTube, feel free to drop a comment or a chat in the live chat. I have it up. Or if you're also watching, don't forget to like and subscribe and turn on the notification bell. But yeah, go ahead and open up the floor to questions.
How would you rate the value of these three tools together? And is there another set of three tools that's sort of comparative?
In terms of open source, it's pretty simple to set up. Once you figure out how to do it, writing your DAGs, it's essentially just, as long as your DAGs work, you should be able to orchestrate your data processes, right? You could potentially swap out Presto for Spark and then use Spark SQL, but then you have to take into account Spark and Presto, Spark resources. But Presto, you also have to take into account resources. But something interesting that I came across while doing my previous Airflow and Presto talk was this library called Presto on Spark. I'm still looking into this. I haven't done a ton of research, but I thought it was pretty interesting, where it's essentially a way you can run Presto code as a library within Spark Executor. So it's kind of the best of both worlds. So you get the utilization of Presto using Spark's distributed processing. So I think in terms of comparisons in the open source realm, I mean, Airflow has its open source different Python, like Luigi or something of the sort. And then for Presto, again, you could do Spark SQL, and then there's some other open source SQL query engines. But I think in terms of the power of Presto and Spark SQL, they're kind of up here versus some other ones that are maybe for smaller things. And then for Cassandra itself, Cassandra is Cassandra, right? So you could potentially swap this out. Like Presto has a ton of different connectors, but in the realm of NoSQL, you just have to check through the Presto Cassandra or Presto connector list.
Thanks.
Okay. Anyone have any other questions? All right, doesn't look like there's any more questions. We'll go ahead and wrap up here for today's talk on Presto or Cassandra, Presto, and Airflow. Don't forget to like and subscribe if you're watching on YouTube and turn on the notification bell. And we will see you guys on Monday for Data Engineers Lunch, as well as Cassandra Lunch next week on Thursday, same place, same time. And with that, yep, we'll go ahead and wrap up. Everyone take care.
Thanks, Arpan.